Hi there, I'm in the absolutely stunning Klein Gardens, which is where I normally come for my daily exercise. It's absolutely full of life here. You can hear the birds singing, I've seen tons of squirrels running around, and it's just, there's so much life going on, but more importantly, it's full of colour. And I'm going to explain to you why that's really interesting.
Now, the most colourful thing in Klein Park is definitely the flowers, who use their bright colours to attract insects for pollination. But there's another part of the plant that's colourful that I think uses colour in a much more interesting way, and that's the leaves. Hi, so I'm back from my run now, and I managed to fetch some leaves from Klein Park as well as get some from my garden in order to explain to you how they use different colours of light to make their energy. Light can be broken down into various colours like a rainbow, but we actually use 3 primary colours, and you can see these if you look really closely at a TV screen. You can see it breaks down into red, blue and green light. As I'm sure you know, leaves tend to be green, which means that they reflect light. They reflect green light and absorb red and blue light. Now, this red and blue light that they absorbed is taken in by their cells, and they use this to make energy and sugar that they can use to grow. There's a lot more going on than just green light being reflected. If you have a darker leaf, more light is absorbed and less light is reflected, which is why it looks darker to us, which means it's actually taking in a lot more light and able to produce more. If you have lighter leaves, they tend to reflect more light, which means less light is being taken in for energy. But this one I think is actually like a little bit yellowish, which means it's got more red pigment in, which means more red light is reflected and it's taking in more of the blue light. While most leaves are green, some are actually really interesting colours, such as this one, which is a bright sort of purpley red, very burgundy. Which would actually mean that this one is a mixture of blue and red light, mostly red light that's being reflected, which means that this is one of the few leaves that's actually taking in lots and lots of green light. So that's what I think is really interesting about leaves, is that just because a lot of them are green, they aren't all green, and they use different wavelengths of light, which equal the different types of colours. And that's how they're able to make their energy. So that's how leaves use their different colours of light. And now I'm going to pass over to Kristi, who's going to explain to you how humans can use this same kind of process and technology in order to improve our own lives.
Thank you, Alex. So we've had a look at how plants can take sunlight and convert it into food to be used as energy. Now, human cells can't do that, but humans have found a way to take the energy from the sun and use it as an energy source for their homes, and that's with solar power. And with solar power, you need solar panels or solar cells, like the kind you might see on some people's roofs. And there are a couple of different types. One type is called photovoltaic. And the photo in this word just means light, and the volt is to do with electricity. So it's just a way of saying that these are panels which convert light straight into electricity. And they do this because everything in the universe is made of atoms. And these atoms themselves are made of little particles. One of the particles is called an electron. It's a tiny little negatively charged particle that whizzes around the outside of atoms. With the material inside a photovoltaic solar panel, these electrons will absorb particles of light called photons. They'll absorb some sunlight and they will take the energy from those photons, take energy from them. But when they take the energy, the electrons themselves become more energetic. They get more energy, they start to move around a lot more. And if they get enough energy, they can actually escape the material. And when they escape the material inside a solar panel, we can channel them through wires. And that's all electricity is. That's all we need to do to create electricity with a solar panel. Because electricity is just the flow of charged particles like electrons. If you plug something into that wire, like a laptop or a phone, They will take a little bit of that energy from those electrons, and that's what will power the device. Now, in a lesson we did last year, we built our own photovoltaic solar panels or solar cells. To do this, we had some glass slides which allowed electricity to pass over them. They were conducting. And then we put on top of that a layer of titanium dioxide. And the reason we used it is titanium dioxide is a material that when it's given energy, it releases its electrons. So it does what we want it to do. But it's white. And when light hits white surfaces, it's reflected off, and that's why white things look white to us. So the titanium dioxide won't absorb any energy from the sun. So what we had to do is we had to dye it, we had to stain it another colour so it would absorb some colours of light. We did that with raspberries. So we mashed up some raspberries, and the thing that makes raspberries look red is a natural pigment called anthocyanin. So we mashed up the raspberries, we put it over the top of the titanium dioxide, and that stained the titanium dioxide red. And now, because it's red, because it's covered in anthocyanin, it will absorb certain colours of light. And now it can do that. Now this titanium dioxide can absorb sunlight. It could release electrons. So we had working solar panels and we measured the electricity coming off of them. Now, that's not something I can do here at home. So I'm going to go at making a different type of solar panel or solar cell. I'm going to make something called a solar heater. Instead of taking sunlight and converting it into electricity, these solar heaters will take the energy from the sun and use that to heat water. What I'm going to need is a container with a lid. I'm going to need a thermometer, and I'm going to need a pen and some paper to write down my results. So I filled my container with water. I'm taking a starting temperature, which is 15 degrees Celsius. Now I'm going to seal it up, leave it in the sun for about 30 minutes and see how that temperature changes. I'm now checking the temperature again, which is 17 degrees. So not a lot, but we have managed to heat the water using just the sun. So we've had a go at making our own solar heater and seen that even our homemade version can heat water, even if it's just a little bit. But a lot of research goes into making solar panels and solar cells more efficient. So getting the photovoltaic cells to create more electricity, or getting the solar heaters to heat water faster. There are loads of different things we could have changed. We could have made our container, we could have used a container with a different material, we could have used a different size, we could have filled it with a different amount of water, different colours, all kinds of things. Have a go at making one of these yourself at home and see which design is most efficient. Let us know how you get on, but for now, goodbye.